Mislim da je vreme da otpočnemo sesiju. Imamo malu izmjenu u programu zbog leta profesora Iona, tako da bih I want to invite Professor Ion on stage. So paradigm changes from comfort to decarbonization through energy efficiency.
Okay. Hello, good morning. My name is Jan Bistran. I'm here with my colleagues Ms. Silviana Brata and Ioan Silviu Dopoși. I want to present you one Romanian tools for rated APBD. The context is the objective of European Union to 2050, rated carbon neutralization. As you know, in the past there was some steps rated energy performance of building directive in Europe, starting with 2002, rated energy performance certificate, rated minimum energy performance requirements. Then continue with 2010 nearly zero energy building concept and ZEB. And the last one, it's important step, it's 2021, rated zero emission building concept. In this context, we can discuss about legislation in Romania. Starting with 2010 was introduced law 372, rated energy performance of building. In 2006 was developed a methodology for calculating the energy performance of buildings, and the next step was in 2016 rated the level or energy demand of nearly zero energy building in Romania. 2017 was an order rated modification of concept of the methodology for calculation the energy performance of building. There was some update rated the first methodology, and the last step and important step was made last year, rated a new methodology for calculation the energy performance of building. In this context, we develop starting from July 2007 one Excel file we call DOSET PEC. PEC means performanța energetică a clădirii, energy performance of building in Romania. And after a few months, we start to develop a software tools. The second image from the left is developed in Visual Studio for Microsoft System Operation. And then we develop new version for building, new version for apartment, in between 2008 and 2010, and one important step was in December 2010 when our tools was approved by Urban Incerc. It was the first Romanian software rated APBD approved in Romania. And the next year, the next step, we introduce new modules. In August 2020, we start to update the software according to the new methodology that was starting to develop. And in this year, in 2023, that new methodology was approved, and we continue to develop our software to update with heating and cooling demand calculation, new lighting modules, thermal zones, renewable energy systems, and in February this year was launched the new version. And now the current is in use. I want to present some windows rated to these tools. This is the main windows with a list of all projects that was made. And of course we have a lot of menu, sub-menu here and buttons bar, sorry. One important Windows is rated auditors register with all the project that was developed. And the step for work with these tools are I will present in the next windows. The first one is to create a new project, and also you can update the data what was introduced. The next step is to introduce the building envelope elements, and the third step is to define the thermal zones, to introduce the technical system for installation, and of course the final scope is to have energy performance certificate. Also for this Windows we have two versions, in Romanian and in English. And in the right panel, I don't know if it works. It's a panel with primary energy consumption. The update in real time all this data. And for the certificate, we need to have Appendix 1 with recommendation, Appendix 2, Appendix 3, and also we have a Windows rated calculation summary, and a lot of Windows rated libraries for materials, Windows, isolation, and so on. And of course, in this new update, introduce concept of NZEB, and we have also a Windows to check if all the it's important to check if the step is it's in according with law and methodology, and to confirm it's that building is NZEB or not. And also we study and introduce some ration or value from European standards. And in the last part, I want to present a case study, rated energy performance certificate for a residence building located near the Timișoara. As I mentioned, the first step is to introduce the envelope elements. Here the Windows related ground floor definition, and in the chart we have multi-ground floor heat transfers. And the next step is to introduce the external wall definition. Here the list of the walls. There are 4, and below the image is rated the layer of each wall. The next element is windows or external door with definition for them. Floor above last level. We have here one floor and with layers. And the next step is to define the thermal zone. Of course, for this building, the residential building, we have only one zone. And of course, the software calculates the monthly heating demand, as you can see in this chart. And next step is to define the consumption of lighting. Here it's Windows where we introduce a lot of information to prepare calculation for lighting. And the new methodology comes with renewable energy, and we introduce new windows in our tools, rated photovoltaic panels, solar heating, and heating pumps. Here we have an example for photovoltaic panels, and in the left it's Windows to introduce all the data, and the result it's in this chart, monthly electricity production in kilowatt hour. And of course, as I mentioned, the final scope is to elaborate this energy performance certificate. And in the left we have energy performance in class A+ till G, and in the right side, I don't know if it's visible or not. No, we have level of CO2 equivalent emissions, and in below we have the results for energy class annual specific primary energy consumption per utility, per heating, domestic hot water, cooling, mechanical ventilation, and also for lighting. And as I mentioned, in the right panel, it's displayed the total primary energy consumption in a real time after if you introduce one new element or modify some element of envelope or installation, we update that panel, and we can see in real time the values. This was all for my. If you have some questions, if not, thank you very much.
Can I ask one question to complete the audience? It's not related. Is it okay for you if we move the table from here? It will be on the left side because we absolutely don't see the presentation.
Thank you for a nice presentation.
Thanks a lot.
I want to invite Andy Patterson, energetski efikasni sistemi za pripremu vazduha u klimatizaciji. So, please.
Okay.
Thanks a lot.
Thank you. Good morning, ladies and gentlemen. I'm very happy to be back here in Belgrade, and it's a real delight to see that the KGH conference, which has been so energetic for so many years, is continuing that strong tradition. So thank you for inviting me. I apologize to those of you who may have seen some of these slides before, possibly nearly all of these slides before, but there is a little bit of new information at the end, so hopefully you stay awake long enough to catch that as well. This is a summary of work that I've been doing for about 6 years, and I tried to cram 6 years into half an hour, so of course some bits are missing. But these are the kind of places I've been presenting this before, and it's been a journey. I did not expect to still be doing this in 6 years' time. When I started that process, I had a fairly simple idea, but it just kept on growing. Every time I finished one element, there was another piece to do. So this review covers work that's been presented since the International Congress in Montreal in 2019, and at various places, the Gustav Lorentzen Conference and the Ohrid Conference twice in Macedonia. And the ideas have been developing as they go, and they've been built on feedback from speaking to groups like this and from discussing with my colleagues and trying things in practice. So it really has been a building exercise. To start with, we need to think about energy use in industrial refrigeration systems. And the objectives are to understand why it varies so much when there seems to be no apparent reason for the variation. So reducing energy is an absolute top priority now because the costs are rising all the time, but there's still a massive variation from one site to another. A study done on behalf of IIR that reported in 2013 showed that the average energy consumption in cold stores in Europe was around about 50 kilowatt hours per cubic meter of storage per year. But the UK had previously published a best practice curve, I'll show you in a minute, which said that 30 was a suitable best practice. And the work that I did in Montreal for the International Congress suggested for that size of store that 10 was a more appropriate best practice number. So if the best practice is 10 and we thought it was 30 and the average, just halfway point, is 50, that shows you what kind of a variation is happening in the real world. And that's unacceptable because that means that many stores could be much, much better than they are, and the operators should be benefiting from the lower energy costs. So measuring kilowatt hours per year and dividing by the volume of the store gives a really, really useful benchmark. It's only two numbers, and everybody has these two numbers. You all know what size your cold store is, and you all know how many kilowatt hours you used last year because it's on the bill that you paid. So it's not difficult to get the numbers, and all you have to do is divide one by the other. And that gives a benchmark between two different sites and also over time for one site, provided you have a long enough period with the information. So Floor area could be used, but that can sometimes give misleading results. And best practice figures from around the world show very close agreement. I've done this work based on UK data. I've looked at European data. A colleague, a friend, did a similar exercise in Australia. Other people have done the work in the United States. And what they've really taught us is that good practice is good practice wherever you are in the world. So the benchmark doesn't actually change whether it's in the southern United States or northern Australia where it's much hotter. The best practice benchmark is the same. And process cooling makes it more difficult, so I'll talk a little bit about process cooling as well. So what are the things that affect building energy performance? How busy is the building is an obvious one, and what's the weather doing outside? That has two effects. It affects the heat gain on the building, and it also affects the discharge temperature and the performance of the refrigeration plant. So there's a double hit there. How good is the condition of the building? Is it losing a lot of thermal property over time and allowing more heat gain? What about the doors? Are they allowing lots of air in because there are large gaps? And then how is the building being operated? Are the management very strict about air ingress, or do they not really care? And finally, what condition is the refrigeration plant in? Now, if you think about these 5 things, 4 of them are related to the way that the building interacts with the refrigeration system, and it's only the 5th one that is actually based on the condition of the refrigeration system. As a refrigeration guy, I can really only address the 5th one and make observations about the other 4, but all 5 of them are important. They work together to give you either a best practice building or an average, what I would call rubbish building, or even the other end of the scale, the ones that have dragged the average up so far, the really bad ones. All of them are relevant to the amount of energy that is needed to do the job. And remember, the job is maintaining the temperature of the cold store. So that's the key thing. If you're not maintaining temperature, then you're not delivering the necessary outcome. How much energy do you need to deliver the necessary outcome? So this is the graph that I developed for Montreal, and a very simple equation. The yellow line that goes horizontal is what the UK government decided was best practice in 1994. And you can see 30 kilowatt hours per cubic meter per year. The 3 lines above it are European averages for chill stores, cold stores, and mixed stores. And you can see that in one case it's very, very far above the best practice line. But the blue line there, which is based on this equation, 15,500 times the volume of the cold store raised to the power minus 0.63 gives you that curve, and that shows you what a best practice cold store would look like. And these dots that are on the graph are for a wide range of sites for which I had the data. The different colors represent different types of sites, but you can see that most of them are between the yellow line and the blue line. And it's not going to be possible to get everything down onto the best practice line, but I would say provided they're in that, what I would call the good practice zone, then I think you're doing quite well. The question is still, can you improve? So that's a starting point, is knowing what your specific energy consumption is, and then you take that from there and say, what can I do to make it better? And effectively you gamify the process, you turn it into a competition. How can I improve this? So it's actually a really simple equation based on very simple information, and I don't understand why more people are not doing it. This is why I've carried on with this exercise. When we think about process cooling, it could be all kinds of things. It could be glycol chilling for a pharmaceutical plant, like the picture on the far left. It could be chilling of products in a bakery, or computers in a data center, or it could be making flake ice, or freezing chicken, or blast freezing of fish in a blast freezing plant. All of these things are process cooling. And as you can tell, they're all very, very different, but they all are consuming additional energy. And if you have a central plant that has a cold store with a fixed volume, but one of these things attached to it, it becomes much more difficult to assess the energy performance. But it's not impossible. So the things that identify an additional load as process cooling is the cooling load's variable. It depends on the product quantities that are going through the plant, and on the incoming temperature of the product. You know, if you're chilling milk in a dairy, you know you want the milk to come out at 4 degrees, but you don't actually know what temperature it's arriving. It's difficult to calculate what the cooling load is. you have to put some assumptions in. So these three are all related to the substance itself. It depends upon whether it changes state or not. Are you freezing the product, or are you just chilling it? Are you just trying to lower the temperature? So these are to do with the state of the product. And then finally, it might be done in batches, or it might be done in a continuous flow, and they're to do with the process stream that it's related to. So putting all that together, the end condition is known, but the start condition is undefined. As I said, you don't know what temperature the milk's going to arrive at, but you do know what temperature it needs to finish at. So we can characterize it according to these three things: the substance, the state, and this gives us a matrix of 8 different possibilities. If we're talking about chilling a liquid in a flow, then that would be something like a water chiller, you know, a fairly typical piece of equipment. If instead of chilling we were freezing, then it would be a flake ice maker, like I showed you in the photograph. It's freezing a flow of water, so that characterizes it. If you weren't taking a flow, it was a batch, then that would be a tank chiller, you know, a big tank with a coil in it. You pull the temperature down and then you stop the refrigeration plant. Or if it was freezing, that would be a cube ice maker. You're making batches of ice rather than a continuous flow. If we're dealing with product instead of liquid, then these would be a spiral chiller or a blast chiller, and a spiral freezer or a blast freezer. So these 8 different systems can be characterized by the 3 parameters that I spoke about. The substance, the state, and the flow. So when we look at these characters, I get a tag here. Is it liquid flow chill, LFC, or is it product batch freezer, PBF, or something in between? And that will determine the way that I analyze the energy use that is fed back into the overall system. If you're freezing something, then this is a typical graph that would show what happens over time to the temperature of the product. Fairly quick pull down to freezing, then it goes very slowly. In most products it's not actually horizontal because there are salts inside the cells in the product, and therefore as you freeze some of the water in the product, the remaining solution gets slightly saltier, and therefore the freezing point drops a little bit. But you've got that almost plateau, and then once the last water is frozen, it starts pulling down a bit faster again. But if you consider the enthalpy, the heat that's in the product, you get a kind of similar looking graph, except it's a bit more smooth at the beginning, and it's only once you reach the end of freezing that you get that final pull down. And the size of that orange line is an expression of the duty being done by the refrigeration system at that point. Maximum duty is actually done at the beginning, and then as you're pulling enthalpy out in the middle of the process, the refrigeration plant can't work as hard, and then it tails right off at the end. But you need the core of the product to be down at the desired temperature, typically -18, so you're not finished until the center is down at temperature. The edges will be much colder than that, but to get the full process, you have to keep it running for a very long time at the end. There's that long tail to deal with. So, batch freezing, the process energy consumption needs to be related to the product throughput. It's nothing to do with the volume of the cold store, and therefore we've got a mismatch. We've got one, the store energy is based on kilowatt hours per cubic meter over a year, but the product throughput is based upon per ton, and it doesn't matter whether that ton went through in a week or a month or a year, it's a per ton figure. And the only way to aggregate them together is to take the product throughput for a year, and then you can finally build a composite. But using a sample time that's less than the batch cycle could give you a misleading result. As I said, there's a lot of refrigeration done in the early period. If that freezing cycle took 2 days and you were looking at energy consumption per day, it would be very high every second day, and it would give you a large error. So for different types of food, that enthalpy reduction varies greatly. If it's bread, it will be very low because there's a low water content. Maybe it would be 150 kilojoules per kilogram, all the way down to fruit and vegetables are almost all water, so 350 kilojoules per kilogram would be an appropriate figure to use. And these 3 cases here, process energy consumption 1, 2, and 3, that are in these right-hand columns on the screen. The first one is a kind of ideal scenario. You've got fan power to blow the air, and I've assumed that the fan power is about 30% of the total, and therefore the product freezing is about, the heat coming out of the product is about 70% of the total cooling load, and I've assumed that the COP is about 1.8 in this case for the freezer, and that would require the quantity of energy that I've shown you there for the different types of product. Fruit and veg, 118.8 kilojoules per kilogram per ton. Sorry, kilowatts per ton. If the fan power is actually higher than that because the design of the freezer is not very effective, let's say the fan power was 50% of the total cooling duty because higher power fans were required, but the refrigeration plant was still 1.8, then you would require this amount in kilowatt hours per ton. And if the refrigeration plant COP was lower and the fan power was higher, then it would be this scenario with this is based upon 50% is fan power and a COP of 1.2 for the freezer. So you can see there's a big variation in the kilowatt hours per ton. What I found when I looked at data for freezers was they were much, much higher than this. They're very far away from the ideal. We're using much, much more electricity to do the freezing job than is actually necessary. So combining SEC for a warehouse, that's specific energy consumption, that's per cubic meter, with process energy consumption, which is per ton, it's difficult. You need to take an annualized figure for the store, so you would need to look at what your PEC would be on an annual basis. But you can combine them by annualizing the process. The bottom curve here is that blue line that I showed you before, the best practice curve for just a cold store, and the contours above it are based upon these different annual throughputs for freezers. And you can see that if it's a very large cold store, even a large throughput is not making a massive difference to it in terms of the best practice curve, which is PEC1 from the table that I showed previously. If it was a product that requires much less energy to freeze, for example, in this case, just static freezing of butter, which is very common in New Zealand where the data came from, you can see that the curves are much more closely bunched together. It's going to be dominated by the cold store rather than by the freezer, because the freezer is just putting pallets of butter into the store. So that then took me to the point of predicting what the specific energy consumption is going to be, and that might be a strange step to take. You know, I've been talking up till now about historic information, but you have to wait a year to get a year's data in that case, and sometimes we want answers faster than that. So there are two reasons why you would want to predict what the specific energy consumption is. And the first one is that if the operating conditions have been deliberately changed, for example, you replaced an old worn-out compressor with a new compressor, you might want to know what the energy benefit of doing that was. Or if you cleaned out the evaporators and made their performance better, you would want to see the effect of that. Or if you modified behavior, for example, increasing the discipline on the closing of dock doors in the cold store. But it might also be important to understand the effect of a change that was unplanned. If you've made these changes, you made the plan and you want to know the result before it gets overwritten by other changes that are occurring. If you assess the SEC frequently, it also helps you find out when something has gone wrong that you wouldn't otherwise have noticed. A silly example, a plastic bag blew over the air inlet in the condenser and blocked the flow and made the performance worse. How long would it take you to discover that that had happened if nobody's going up on the roof and looking at it? So accounting for weather was the first thing. When we looked at the historic data, this is the weather pattern for the site that I was looking at based over several years. That's about 3 years of weather. And this is the energy consumption in kilowatt hours per day for the same site. Now, if you're old enough, you might remember US Vice President Al Gore made a video in 2006 called An Inconvenient Truth, and he was looking at the hockey stick curve for global temperatures and CO2 emissions, and he said, do you think these two ever fit together? So the same question applies here. Looking at these graphs, do you think these two fit together? The answer is not as well as you might think, because that's the same data, but it's plotted on ambient temperature against the kilowatt hours. So you can see there is a correlation. It's definitely higher at this side than the other side of the graph, but the spread is absolutely massive. At any point, it's about plus or minus 50% of that middle figure. So taking 1 day's information, is that likely to be in the middle, or is it the plus 50%, or is it the minus 50%? If we use the red line, sorry, the yellow line, to create a correlation and back that out of the data, then we get this graph, and you can see that the variation is still huge. The daily reading is about 15,000 kilowatt hours, and the variation is plus or minus 10,000. So what it does say, though, is if you aggregate data even over a relatively small period, you will create a smoothing effect that balances that out. So difficult to tell. The positive discrepancy means less power, so maybe the store broke down and it wasn't running that day. That would be one reason why the kilowatt hours figure was low. How do you explain a positive figure, power higher than predicted, even twice as high as predicted for those operating conditions? Something's affecting it. It might be the daily averaging is masking something else. But it's still a very useful technique. What we did was we took historic data for 20 sites over 3 years, analyzed it, and then tried to fit a curve to it. Firstly, using a power of 4 polynomial, and then using a sine wave. So there's the polynomial and the sine wave. What we found was that the polynomial was actually a slightly better fit to the data. But what I realized was I prefer the sine wave because if you notice, the beginning of the polynomial fit is very high, but the end is quite low, whereas the sine wave repeats year after year. So if you're going to use this to predict things over more than a 1 year span, then the sine wave gives a better result. And the sine wave actually means something. The factors in it, h at the end is just 1 divided by 365. What we're doing here is that P is the proportion of the total energy that we expect to be used on a given day. And if there was no variation at all, then that proportion would be 1 over 365. So the H is that offset. The F is a scalar between the maximum and the minimum. And the G is the number of days offset to the minimum point. When does the lowest point occur in the year? And that then allows you to use the sine wave to make a prediction. So, how to display it? Well, there are 2 ways. I showed you this before. This is for lots of sites, but it's a fixed point in time. The dots in the graph represent a single calculation that was done for that site. And that's very useful for comparing from one site to another. But the alternative way to draw it is like this, where every day is a new prediction or a new calculation of what the SEC is. So it's a development over time. And the red line shows you SEC calculated from the last 365 days, and the grey line and the green line are predictions using the sine wave that I showed earlier based upon a smaller number of days data. In the case of the grey line, it's based upon a single day, and in case of the green line, it's based upon 30 days. So you can see that the grey line is all over the place. As I said, it's plus or minus 50%, but it's still giving an indication of where it's going to. Now, in this, I used historic data, but I fed it into the mathematical model 1 day at a time to build up the prediction. So it's a genuine representation of what would happen in real life. I didn't know the answer when I started the model. But partway through the model, after 166 days, I put in a fake improvement. I said, let's pretend that we've done something that reduced the energy by 20%. So all of the energy figures after day 166 were 20% less than they'd been before. And that occurred here, and you can see the grey line dropped immediately, the green line dropped very quickly, and the red line started to trend down over time. So you get a very quick indication that something has happened, but it's still quite wild. There's a large margin of error in terms of predicting the actual result, but you know the direction you're traveling in. And then the red line gives you the final answer over time. So some other things to think about. If you've got more complicated plant, then there'll be other things to think about. Is it seasonal? How about product throughput? Even if it's a cold store, you might have lots of pallets going through the store 1 day and nothing at all happening the rest of the time. Think about a store holding Easter eggs. It's very busy in the run-up to Easter, but it's very quiet for the rest of the year as they're building stock. Or we did a flower store recently for a company that was transferring flowers, and they said there are only 4 busy days in the year. There's Mother's Day, there's Easter, there's Christmas, and I can't remember what the 4th one was, but the rest of the year it's very quiet. So there's that kind of a factor. Is the heat load constant or is it variable? Are there other things that come into play? and what parameters are driving the variability. And I have to say I failed at this point, because I looked at weather, I looked at wind, temperature, wind gust, humidity, and none of them improved the correlation. It was really quite strange. The only correlation I found was that if there was a day with high gusts of wind, then the energy performance tended to improve on those days. And I can only conclude that people thought it's a bit rough outside, so they were naturally more cautious about door discipline, and they actually improved it for the wrong reason. So there is a correlation, but it's not what you would expect is the answer, and it's not very helpful. So the SEC predictor is a brilliant way of understanding what's driving variability. This case study looks at the type of system that we've been installing a lot of in the United Kingdom. These are ammonia packaged refrigeration units. The evaporators in the cold store, everything else is in this condensing unit. Each of those provides about 300 kilowatts of cooling to a cold store at about minus 20 degrees C, and those two are serving a store of roughly 80,000 cubic meters. That is the ammonia plant. There is no plant room in this building. That's it. It's all out in the open, very compact. And we had data recorded on a daily basis for this site. And that shows you what was typically happening. I think this is April of 2001. You can see the red line, the actual result is very flat. The blue line, which is the very short-term prediction, or the small data prediction, just 10 days of data, is dropping. That means that the system is improving, and gradually over time you would expect to see the red line turn down. I call it long-term prediction because it's looking 355 days ahead based on 10 days data. So long-term means small amount of data, it's less accurate. So there you go. It shows there's been a recent improvement, and the full year figure can be expected to fall further. But this is what was happening 6 months earlier on that site. And you can see the blue line is kind of all over the place, and the others are all trending upwards. So what was it that was happening? As we dug into it, we find that in October, the long-term prediction was the lowest, showing that recent improvements had been made, and the store was gradually getting better. However, 1 month later, the long-term prediction, the 10 days data, you know, the short range, was the highest by a significant amount. Something had changed substantially, but it was recent, so it didn't affect the short-term prediction, the 90-day data version. And then 6 months later, it had turned around. The red figure was now quite high because of that impact, but the blue was back down again, and it was back on that improvement path. So we looked into what was happening, and what was happening was that 80,000 cubic meter cold store was being extended with another 80,000 added at the back. And at the beginning here in October, they started commissioning the second cold store. So it was opened up, and suddenly the 80,000 became 160,000, and the new equipment was being brought online. So we started pulling down the cold store extension at that point, so the load went up further. That was the end of the pull down, but they started stockpiling, so there was a huge amount of traffic into the store. And then came Christmas, so there was a Christmas break, and you see immediately there's a dip, and then that's the end of the Christmas break, and they carried on stockpiling, and at the end of stockpiling, the numbers started coming down again. So the blue trend was actually giving us an insight into things had happened, and when we looked back, we could see what it was and how it was affecting the kilowatt hours. This is an update to the figures. I'm not sure, you can see the date on the bottom there. This was just taken last weekend, and you can see it's now at 7.6. And yes, the blue is still all over the place for the year, but the red line is trending down. We've seen things happening and we've responded to them. We're using the tool to figure out, are things going well or are things starting to go off? And 7.6 is less than that best practice line that I showed you. The best practice would be about 8.3, I think I calculated from the equation. Yeah, 8.3. So over a year, the plant was using 7.6 kilowatt hours per cubic meter. I don't know, what in Serbia, what would you pay industrially for a kilowatt hour of electricity? Somebody give me a number. No clue. Okay, well, I'll give you I think I put it in dollars in the calculation I did. If you were a European average store at 40, instead of being this store at 7.6, you would use an extra 4,900,000 units of electricity per year if you were paying 20 pence per kilowatt hour in the UK. That's £1 million. So the energy difference here is saving the operator £1 million compared to something that is very common around Europe. It's that size of saving that can be made. And that would be enough to buy one of these plants. You know, it's a very, very short payback period. So we developed a tool. This is based on an Excel spreadsheet. If, as I said, the P in the sine equation is giving you the portion of the total year's kilowatt hours that applies to that day. So if you know the start day and the finish day and the number of kilowatt hours used in that period, let's say you started measuring on the 5th of March and you finished on the 10th of April, so that would be 36 days. You could put those dates in and the number of kilowatt hours, and it would say, I predict that your specific energy consumption will be this amount kilowatt hours per cubic meter per year, and the margin of error is this much. So very, very useful for just taking a snapshot with a small amount of data. We turned that into an app, so you can have it on your iPhone. You put your details in, put in the volume of your cold store and your annual kilowatt hours, and it plots your SEC on a graph, and it shows you how you compare with anybody else that has registered for the app. So in concluding, they're both essential tools in managing energy consumption, and they can motivate a policy of improvement through investing wisely in specific things like a new compressor or a condenser clean or whatever it is that you do. But they also help to make sure that you know that the store is as healthy as possible, which is really, really important. So it should be evident within a few days when you make a change. This can be very, very easily retrofitted to existing sites. It's not something that you need to install with new plant. We've been using this technique on plant that's 20, 30, 40 years old, and it's really, really powerful. But it helps to manage the operating costs, gives better control of maintenance, and better control of investment decisions. So really useful. And I saw you had a slogan here, all I need is the air that I breathe. I would add to that, all I need is the air that I breathe and some data. It's not very much data, but it's really necessary. So thank you very much for listening. I'm very happy if you've got thoughts or questions, particularly about ways that you could take this tool and do something different with it, because then I'll have to carry on this journey of learning and expanding and moving forwards. So thank you very much. It's been great talking to you.
Actually, lots of questions.
Okay, good.
But I will start with first of them. You mentioned lots of influencing factors in operating your systems, such as weather conditions, loads in the storage, variation of product types in the storages. My question is, how fast or how important is that your system is acting fast to amortize these changes or different parameters that are coming? And second, is there any learning curve? Is there more software or hardware utilization to overcome these changes in operation? Is there any AI learning curve that is optimizing your system running in this kind of environment?
Okay, I think there's two things to say there. The first is that some of my colleagues have been working on that aspect, and including the use of AI to figure out, and we will be presenting a paper in the Cold Chain Conference in Japan in June next year, so there's still more to come even now. But what they're doing there is they're taking all of the performance data. You know, I was saying I only need the size of the store and the kilowatt hours, but they're taking everything about the plant, suction pressure, discharge temperature, kilowatt hours consumed by the compressor, and so on. They take that off-site and they do a huge amount of calculation on it, and they look at every component in the refrigeration system and they say, is it healthy, or is it getting just a little bit jaded, or is it really quite sick? And they show a graph in terms of a square for every day that goes either green or yellow or red, depending on how healthy the component is, and you can see it just drifting off over time. It's really powerful. And what that does is it points the maintenance guy to the piece of equipment he needs to deal with. He might say, oh, my compressor is consuming too much electricity, but the problem's not with the compressor, the problem's with the evaporator or the condenser or the pump or something else. So our tool but it's huge computing power, so it needs to be off-site. You couldn't build all that on a site-by-site basis. It would just be too expensive. But you can have a central hub and bring data from lots of plants and do the calculation at the central hub. So we're doing that piece as well, but it didn't feature here. But the second thing is, that really only says to the maintenance guy, here's a haystack. I'm confident there is a needle in the haystack. If you said to him, yeah, there might be something wrong with the haystack, maybe there's a needle, go and find it, he's not that committed to finding needles in haystacks because he's not convinced that there's really a problem. What we've got now is a really powerful tool for saying there's a needle and it's in here, go and get it. And worse than that, or better than that if you like, we can say to him, actually there are 3 needles in that haystack, so go and fix all 3 problems because your consumption of electricity won't improve until you've addressed all 3 of them. If you go and find something wrong and fix it, and you don't see a benefit, you'll be very disheartened because you think, I didn't make any difference. Actually, you did make a difference, but there are 2 other differences that have to be made as well. And the way that AI helps with that is that it can look at, firstly, creating a digital model of the plant so that we can do that off-site calculation, and then fine-tuning it as time goes by and saying, well, you know, with my sine wave, for example, maybe the G factor, the number of days, we calculated it should be 70, but over time it decides that actually 65 would be a better estimate. It can tweak the model as we go forward to bring in these slight improvements in accuracy. But at the end of the day, a lot of that is just about, is it trending up or is it trending down? You know, the temperature doesn't need to be that accurate, the kilowatt hours doesn't need to be that accurate, it's the trend, is it improving or is it getting worse? So what I would liken it to is we used to go looking for faults with plants with a flashlight, you know, a handheld thing. Now we've got this massive 1,000,000 candle power searchlight, and it's so much better at finding things. But somebody still has to go and make that correction, take the plastic bag out of the condenser inlet, or purge the air from the condenser, or do physically whatever it is. The days of the plant doing that optimization and getting that result, I think, are still a long way off, because it's the operator technical intervention, the engineer going to site and making a change is the final step in the process. And the computers aren't going to do that for you. They can tell you exactly where to go and what to do, but they can't go and do it for you. Not yet, anyway. So,
thanks. And second last from my side, since this net zero report and all these other reports, 55 and the others, will demand some increase on renewable. And since we are aware that your company is focusing on natural refrigerants, we could expect some boosting of this kind of demand. How these companies like your company are preparing for 2030 being able to satisfy the market needs, because this will grow for sure?
do you mean in terms of the refrigerant or the energy performance?
Both.
Well, we're kind of addressing both. I mean, most of what we do now is with ammonia, most of the rest of it is with CO2. And it's not because we decided that's what we wanted to do, it's because that's what the market demanded that we do. And I'm going back 30 years or more. You know, the first of these modular ammonia systems that we did was in 1993, so it's just 30 years. And we've been developing that technology for 30 years, and what you saw in the picture was the culmination. And it's the combination of that technology with a well-run cold store that gives us that 7.5 specific energy consumption. If the cold store was well run but the fridge plant was traditional design, it would probably be 15 or even 20 or 25. So still in the good practice zone, but double the energy requirement of what we have here. So we've made a big step in the energy efficiency, and we're already off the fluorocarbon wagon using the natural refrigerants. So the thing about net zero energy buildings is they looked at including cold storage facilities and backed out of it, and I think that was the right decision, because the things that work in the kind of buildings that the first speaker spoke about are not really appropriate when it's a refrigerated warehouse that you're talking about. All of the metrics that they introduce and so on are just inappropriate. So what I'd like to see is a net zero energy for buildings supplement or appendix, annex if you like, specifically for cold storage warehouses that taps into this kind of information about best practice and rates buildings on that basis. But I think that's quite a long way off because there's a huge amount to achieve on commercial buildings before we can get there. And there doesn't seem to be an appetite for doing it in parallel. So we have to wait until they're finished with the first one. But the worst thing would be to try to apply the commercial building rules to industrial warehouses. That would be a disaster. And it looked at one point like they were going that way, and then they backed off just as well.
Thanks a lot.
Yeah. Question, yes.
So, let me understand. You have two main parameters, like the specific energy consumption and process energy. Specific and process energy consumption.
It's coming, I think.
So, it's clear and easy when you have one process at a time, but when you have a big plant, when 5, 6 different processes, are you controlling separate them one by one, and how it influences on whole picture? And even if you control it, I suppose you should put additional equipment for measurement, for everything else, to find out what is the energy consumption, because you couldn't find it from the refrigeration plant where everything is together.
Yes, you're absolutely right. We started from the small scale of it's a modular plant that is only doing one thing. It's only serving the cold store, or we use the same units to do blast freezers and spiral freezers and so on. But one of them just serving a spiral freezer, it's fairly easy to say, well, that will be PEC, and we can calculate kilowatt hours per ton. It's quite compact. If it's a big site installed central plant with maybe 10 screw compressors and 8 freezing tunnels and a large cold store as well, how do you tell? And the answer is you're looking for two things. One is how good is the fridge plant operating? And we can get to that. And the other is my cold store doing well? Are my freezer lines doing well? Is one of them standing out as being the villain, the worst, and the others are better? And that could even lead to a very simple management decision of don't put the French fries down that line, put them down that line unless we really have to put them down that line because that's the poorer performer. Or it would lead to what do we need to do to that line to bring it up to the level of the rest of them in terms of efficiency. So there's a multi-piece there, but it's very difficult when they're all running at once to apportion the blame. So you do start then, you do need to dig deeper. The starting point would be looking at that best practice curve with storage and process combined and saying what is my annual throughput. But then you would need to start looking at when I put 10 tons of French fries down that line, my refrigeration plant operates in this way. You know, that, for example, the liquid line solenoid valve is open for 70% of the time. When I put 10 tons of French fries down that line, they still come out frozen, but the liquid line expansion valve is only open 50% of the time. Why does this one need cooling for 70% and this one only 50%? That's when you take that searchlight and start drilling down into, is it the evaporator that's unhealthy? Is it the product load that's the problem? You know, that it needed that refrigeration because there's lots of air leakage, there's higher defrost demand. So what it's doing really is pointing towards where the problems lie. And at the moment, I really sympathize with the factory manager faced with that kind of plant because, you know, who knows? Who knows? So it's levels of difficulty, but this is really helping to unpack that and break it down into bite-sized chunks.
So thank you, Andy, for a very nice presentation.
Another question, I think.
I think we don't have time for any question because
okay.
If we have any question, maybe we can discuss after the.
Absolutely.
Maybe because this is a very nice presentation, and maybe we can break, prepare a break for 5 minutes or 2 or something like that, if you agree. To make some.
Yeah.
Okay.
Thank you.
Presenter is Grigor Grigoro, the benefit of the adiabatic cooling. This is that presentation, okay. Yeah. Okay, you can go here.
Good morning, ladies and gentlemen. It is my pleasure to present to you the presentation about adiabatic cooling. So, with the actual times comes more and more the question of saving energy and saving resources. So the water efficiency we talk about is that every climate is different. Here in this map of Europe, you can see the potential, adiabatic potential for the different locations. This is measured in combination between the relative humidity and the temperature, and the water availability and price. So you can see all these locations are different, and the message why we present this is that we should carefully study the precise location, because one location is suitable for adiabatic cooling, another one is not. What means reliable cooling? If you see this graph here, the temperature for certain location, the blue zone is okay, but the red zone is the peaks, and when we are using the adiabatic cooling, we are talking about these peaks. The temperature in different regions is different, and the higher temperatures occur for longer time. Due to the climatic changes, these temperature peaks become more and more unpredictable. That's why the idea of adiabatic cooling is to cut these peaks and to reduce the size of the equipment and the investment costs. Here is an illustration of what I'm speaking about. First, we are saving material and reducing the investment costs by smaller heat exchangers at equal fluid temperatures for the different equipment. And as a consequence of this, we have smaller refrigeration equipment due to the lower condensation temperatures. This is an overview of the two systems. On the top side, you can see the simple dry cooling. This is a water-independent solution. It is suitable for every climate zone, and a range of designs make them a very flexible answer for different applications and regions. Dry cooling enables low maintenance and a very reliable cooling system. Below is the adiabatic cooling. Our trade name is Hydro Blue for this system. The adiabatic cooling uses water to pre-cool the air with a pad system, and the heat exchanger stays dry. This enables the unit for operation 24 hours, 7 days per week, and because there is no recirculation, there is no need of water treatment. Here an example of the dry cooler. You can see on the right side it is the ambient air passing through the coil of the dry cooler, and compared to the adiabatic cooling, the footprint is larger, and the fluid after the heat exchanger is always with should be with higher temperature than the ambient air. This is an overview of the standard dry cooler. It enables for low maintenance, zero water consumption. There is no Legionella topics since there is no water. And there are different design types. As you can see, a horizontal unit, a vertical unit, V-type unit. Disadvantage is that fluid temperature must be always higher than the ambient temperature, and it brings larger footprint compared to adiabatic coolers. Also, the energy consumption at the design point is higher. The HydroBlue system uses water to pre-cool the air with a PET system, and the heat exchanger stays dry. It makes the cooling system more efficient and ready for the hot days. So it has the possibility to work either dry or to start with the water at certain switch point. But there are no restrictions to the use of water. You can use water around the year if this is necessary. There is no damaging of the coil. Compared to dry coolers, the footprint is smaller and the performance is higher. Also, this system enables for possibility to have the living fluid temperature below the ambient air temperature. This is an overview of the adiabatic cooling system HydroBlue. It is with increased performance compared to the dry cooling and or a smaller footprint for the same performance. It is a simple solution to optimize energy efficiency. The design is based on our climatic database, which we have in our software. So for each location, you can select the most suitable PAT system, and this enables for the highest saving of energy and water. Fluid can, as we mentioned, the fluid living temperature can be below the ambient air temperature. The heat exchanger stays dry. No limit of wetting time. Intelligent water supply system, which is measuring the flow of water supplied to this PAT system and regulating it, so we can have the optimal water quantity supplied, and this enables for saving water. There is no need of water treatment, and easy mounting and maintenance of this system, even as a retrofit kit. Minimum water quality must be guaranteed, which means that with almost all industrial type of waters, you can use this PAT system. It is only not possible to use with some contaminated or some wastewater. Disadvantage, it's certain air side pressure drop because of these pads. Legionella restrictions are applied on this unit, and pads are parts which should be replaced after a certain period of 5, 6, 7 years. These are the units which we have in the range of HydroBlue. You can see all of them are V-type of units. They can be either fluid cooler, condenser, or gas cooler. On the left side is the compact size of coolers. In the middle is the data center units, GFW. And on the right side are the industrial units, GFD and GFDV. As I mentioned, HydroBlue is available also as a retrofit kit, which can be very easily supplied by our service office. That means even you have a unit which is not delivered with HydroBlue, you can retrofit it on a later stage if you need more capacity or if you want to make some improvement in your refrigeration plant. The other The other point which I would like to mention is the controls. We have developed our HydroBlue system together with the controls. As you can see, there are a lot of sensors which are measuring the parameters: ambient air temperature, water consumption, condensing pressure, the ambient air humidity, and with all this data, the controller is automatically calculating the most optimal operation mode for certain conditions. This enables for saving water with our patented efficiency mode, and the HydroBlue counts every moment how much water can be evaporated, and it regulates the water supply to the pads. It ensures that the system reaches the performance and economic requirements. This is an example how we are controlling the system. On this switchover point, this is an example for Madrid in Spain, for example. For all temperatures below this value, we work as a normal dry unit. Then, after the water system is switched on, we work in the efficiency mode or constant water surplus, depending on the parameters. And when the temperatures reach the highest values, then we work with full load operation mode in order to provide reliable cooling at all the times. This is an example for a CO2 system which was located in Lyon, France. You can see here on the graph the adiabatic potential which we have, and this adiabatic potential leads to approximately 0.5 better COP. This is also an interesting slide. We have shown 4 locations in Europe from south to north. Interesting are the highlighted values. So you can see the maximum air temperature and the relative humidity, and below you can see the time for return on the investment of the HydroBlue system, and the lower one is the time of return of investment for the complete plant. So you can see that on the south, in Madrid, for example, where there is a big adiabatic potential, the return on investment for the HydroBlue is less than 1 year. And going north, you can see in Germany, or the worst case scenario in Denmark, in Copenhagen, it is more than 10 years, for example, the return of investment period for the system. So that means it is very important to look precisely about the specific location, and then decide which cooler and which system we should use. The HydroBlue system, it is using the standard cell deck manufactured by Munters, which is economic standard on the market. It is impregnated cellulose paper. It provides an efficient wetting, and it has shorter delivery time. Disadvantage is that it is flammable. If flammability is an issue, we have a special solution with Munters glass deck. It is a non-flammable material, but has less efficient wetting, more expensive, and it has larger delivery time. So over the last years, here example from 2019 to 2021, we see more and more water adiabatic cooling is requested from the market. Using the adiabatic cooling makes sense for various applications and locations, and with our know-how we can support for every case the customers when making the selections, and to be in line with the existing regulation. Using HydroBlue is an easy solution that is very easy to adapt to an existing installations, and the intelligent and patented controls will take care about water and safe resources starting from day one. Thank you very much for your attention. If you have some questions, you are welcome.
Thank you very much, Mr. Grigorov. Only one question. Did you make any critical analysis on environmental impact on water consumption? The savings are clear, the efficiency is clear, the return on investment is clear, but is there any special focus on water consumption?
As I mentioned, it is very important to make correct analysis beforehand, before selecting the unit, because this is one of the part of the analysis we should do before selecting the equipment, the price, the location's temperature and relative humidity, and the water availability. It is shown also on this graph, because if water is not available, maybe it makes sense to use a larger dry cooler and more expensive as initial investment, but to save water if it is a very valuable resource for certain place. Yes, for sure, we are making this analysis when selecting, and we have a very large database of locations in our software, which makes much easier to select based on the whole year performance, not only as specified by the designer, for example, 40 degrees and 25 degrees of relative humidity, because this gives no clear message what happens and what is the water consumption throughout the year. So yes, we are making this analysis.
Thanks a lot. Thank you very much, Mr. Grigorov. We will continue. Sorry.
One short question.
Yeah.
Sorry.
This is really interesting topic.
Okay.
But I just wanted to know, you mentioned that you have, I'm sorry.
No, I'm here. I'm listening.
Thank you. Okay, but I think it's...
Just continue, we hear you.
Yes, thank you. So, one short question. You mentioned that you have dry surface of the heat exchanger.
Correct.
Because you have right amount of water sprayed into the air.
No.
I mean,
Yeah.
not sprayed, but
It is
right amount of water. Do you have a model or software how to calculate that? Because that means you will have maybe right temperature of water because of evaporation of that water. What was the catch to calculate that right amount of water?
Maybe there is some misunderstanding because the water to reach the heat exchanger is not a matter of calculation, because the construction of these pads is so that never water is going out of it. Regardless, you can supply 3 times more water than the needed for evaporation. It will not go through. It's not based on the calculation how. You will simply waste more water if you put more water.
Yes, yeah. But I thought you just reconsider the amount of water, but it's...
Yes, we consider the amount of water, but in regards of reaching the requested living temperature of the fluid, and in regards of the ambient conditions, because they are changing from throughout the day, but not in regards to avoid wetting of the heat exchanger.
Okay,
yeah.
I'm sorry. I'm sorry. Thank you.
No. That we can continue this discussion later.
Of course.
Thank you very much.
Artificial
intelligence. Thank you very much. Artificial intelligence and analytics of larger number of data, the tool for running energetic services. Thanks a lot.
Hvala. Poštovane koleginice i kolege, zadovoljstvo je ponovo biti na ovom kongresu i kroz prethodnih 30 godina koliko nastupam i nekih 15-ak radova, usudio sam se da uđem u jednu temu i drago mi je što ovdje ima mlađih jer ušao sam na njihov teren, a to je veštačka inteligencija. Pre 30 godina, kad uđete u postanicu daljinskog grejanja, imali ste čisto mašinstvo, mehaničke uređaje za regulaciju temperature i pritiska, izmenjivač pumpu i to je bilo sve. Danas prva stvar koja se nosi umesto ručnog alata je laptop. Bez toga ništa nećete postići, a preko njega ćete sve uraditi. I gde to dalje ide? Evo, pokušali smo malo kroz jedan projekat koji su Beogradske elektrane uradile prethodne 3 godine. Projekat se završio 1. decembra pre 8 dana. Trajao je 3 godine i upravo smo pokušali da odgovorimo na pitanje šta sa podacima, šta sa sve većim brojem podataka i kako ih dobro iskoristiti. Znači, upravo veliki gradovi, veliki potrošači energije, veliki izvori podataka. Zgrade kao takve, upravo u sali pored nas pričaju kako sanirati ove ogromne energetske ponore koji su trenutno 80% od ukupnog broja zgrada u Srbiji, a ovde prepoznajete, nećemo reći koja je ovo zgrada koja treba da bude prva kao primer, a u stvari ima, rekli su mi, 124 klima uređaja samo na spoljnoj fasadi kao ulici, pojedinačnih split sistema. Ono što je strategija Evropske unije do 2050. godine, kad je oblast daljinskog grejanja u pitanju, je upravo prikazano na ovoj slici. Treba uraditi dekarbonizaciju i treba sniziti temperaturski režim. Mi sada ovde, konkretno u Beogradu i u Srbiji, radimo na ovim temperaturama, sa režimima koji idu i do 100 stepeni, a potrebno je tako podesiti sistem da temperature budu maksimalno 50 stepeni, u prvom redu da bi se smanjili toplotni gubici, a u drugom redu da bi mogla da se primi sva otpadna toplota gde god da ona nastane. Bilo da je u nekim data centrima, bilo da je u nekim marketima, gde god ima rashlade i leti i zimi, da se temperatura preuzima. Naravno, industrija, primjena svih obnovljivih izvora energije i još jedna ključna reč, stvaranje akumulatora toplote. Na taj način, do 2050. Evropa planira da udvostruči broj korisnika na sistemu daljinskog grejanja i da iskoristi sve što može da se iskoristi, a nije fosilno. Naravno, tu treba malo povesti računa i o samoj energetskoj efikasnosti, kako zgrada, tako i ono što možemo sami da uradimo, a to je u potrošnji finalne električne energije u svojim stanovima. Malo pre upravo bilo u sali pored uključenje iz spalionice u Vinči, koja će svojih 65 MW toplotne energije za 10 dana početi da isporučuje potrošačima u Beogradu preko toplane Konjernik, a naravno imamo dosta potencijala na Ceraku, u okviru toplane Cerak je krenuo i novi projekat solarne energije koji će potpuno eliminisati da se tokom leta gas koristi za pripremu potrošne tople vode. Projekat koji smo uradili sa 13 partnera iz 7 zemalja, koji je trajao 3 godine, je imao naziv Beyond i odnosio se upravo na prikupljanje svih mogućih podataka sa svih uređaja, njihovu pažljivu obradu, klasifikovanje i spremanje u module, tako da različiti korisnici mogu da ih preuzmu i iskoriste. Ovde vidite koje su sve firme bile, kažem, iz 7 zemalja, da ih ne nabrajamo. Prvo je urađena analiza koji su to trendovi na tržištu, da se primene obnovljivi izvori energije, da se maksimalno poradi na energetskoj efikasnosti, samim tim mora i zakonska regulativa da se promeni. Mi smo u procesu kao zemlja, procesu pridruživanja Evropskoj uniji i intenzivno radimo na usaglašavanju zakonske regulative i usvajanju i tehničkih pravilnika koji u Evropskoj uniji važe. Digitalizacija je reč koju ste mnogo puta čuli i to je upravo onaj deo o podstanici sa početka našeg današnjeg predavanja, ali upravo produkuje ogromnu količinu podataka. I naravno, gde su podaci, gde je energija, gde su uštede, tu je mesto za biznis. Sa ovim podacima treba trgovati i to je trostruka win situacija gde i oni koji daju podatke imaju određenu korist, oni koji obrađuju pripremaju i oni koji podatke preuzimaju. Znači, ideja ovog projekta je tok, obrada i pružanje podataka gde će svako u sistemu imati određene benefite. Cilj projekta je da se praktično projekat gađa velike gradove, odmah da se razumemo, znači velike energetske sisteme, velike potrošače i velike izvore podataka, a treba upravo da stvori i stvorena je, ja mislim da će u nekoj napređenoj verziji biti dostupna i za javnost tokom sledeće godine, jedna platforma koja će biti zasnovana na istraživanjima koje smo na 4 pilot lokacije tokom ovog projekta uradili. Rezultat toga je, naravno, stvaranje jedne nove vrednosti. Projekat, kao i svi projekti iz Horizon 2020 paketa, su u standardnoj strukturi. Ona je ovde prikazana. Pretpostavljam da ste imali prilike već da se sa ovim načinom rada u Evropskoj uniji, koji moram da kažem da je jako dobar, jednostavan, s jedne strane komplikovan, ali ostavlja malo mesta za razmišljanje. Jednostavno treba pratiti, da upotrebimo našu srpsku reč, hodogram i idemo od početka do kraja, sve nas kroz radne pakete vode instrukcije. Ono što je metodologija Beyonda, polazimo od definicije šta su to korisnički zahtevi, analiza tržišta, šta gde treba. Urađen je prototip, formirane su pilot lokacije, koliko god je moglo da se iste stvari ili slične rade, to je urađeno. Svaka lokacija ima određene svoje specifičnosti i na kraju smo napravili ceo set određenih poslovnih inovacija. Kolektivna inteligencija. Uvodimo još jedan novi pojam, to je integracija lanaca vrednosti i izgradnje podataka. Neću pokušavati da objasnim, praktično vidite da svi koji su u jednom gradu, bez obzira da li su gradske strukture, da li su poslovni korisnici, da li su javna preduzeća, da li su obični građani korisnici, sve je uvezano i svako može preko ovakvih platformi da razmenjuje podatke i da uzima samo onaj segment koji njemu za njegovo poslovanje ili za njegovo unapređenje efikasnosti zgrada, objekata ili proizvoda potreban. Ovde vidimo jedan primer, upravo preko Skupštine grada, preko javnih podataka i još jedna sve značajnija reč, ESCO kompanije. Mi svi ovde više manje znamo šta bismo uradili da unapredimo kod naših stanova, zgrada, naročito kolektivnog stanovanja, ali tu dolazimo sada do problema investicije. Znači, prvi period će sigurno rešiti ESCO kompanije, a dalje kad se točak pokrene, dalje može da ide i samo. Vizija. Veštačka inteligencija koja se odnosi, za sada smo se ograničili u ovom delu na podatke o zgradama i da se naprave takvi ekosistemi koje će vođeni podacima raditi i određeno prediktivno održavanje, ali kažem prvenstveno je fokusirano na energiju, na energetiku i na energetsku efikasnost. Praktično ova platforma treba da predstavlja saradnju između različitih strana, kao što su mrežni operateri, agregatori, ESCO kompanije, gradske uprave, potrošači i tako dalje. Malo samo o tokovima aktivnosti u Beyondu. Polazi se od potreba, mi smo to označili kao hitne potrebe, jer nekad je potrebno u kratkom vremenu brzo reagovati na određene promene. Prikupljaju se podaci, mora da se uradi određena istraživanje i analitika i sve to predstavlja jedan paket aktivnosti sa podacima. Podaci se ekstrahuju, sortiraju, sređuju, posebno se vodilo računa o bezbednosti podataka, jer ovo praktično sve ide preko interneta. Imali smo posebno jednu firmu u konzorcijumu koja se bavila samo bezbednošću podataka i ono što se insistira od ovih kolega iz Evropske unije i sama Evropska unija, trgovina, trgovina, trgovina. Ako vi nemate neki direktni finansijski benefit, onda se postavlja pitanje i koji je vaš motiv da stvarno ovo sve krenete da uradite onako kako treba. Ciljeve projekta smo praktično već i napomenuli, da kroz novu referentnu platformu velikih podataka stvorimo uslove da isporuku energije ponudimo, odnosno podatke o isporuci energije ponudimo kao uslugu, zatim da se stvore određeni podaci u vidu biblioteka i da se stvore jednostavni alati gde će prosečan korisnik, ne govorimo sad o naprednim energetskim menadžerima ili osobama koje su zadužena isključivo za praćenje energije, koje će vrlo jednostavno moći da okruženje prilagode i uzmu tačno one segmente koji njima trebaju. Koje su to tehničke novine? Praktično jednostavno upravljanje podacima, intuitivno istraživanje koje smo upravo pomenuli, sigurno eksperimentalno polje, analitika kao usluga i kreiranje, potpisivanje i validacija podataka. To su glavni segmenti koje imamo. Ja sam inženjer po struci i od kolega koji se bave samo IT-em sam preuzeo ovu referentnu arhitekturu, tako da ću vas zamoliti da me ne postavljate pitanja da objasnim arhitekturu samog, ali ono što je tu ključno da je to interoperabilan dizajn, bezbednosno urađen, radi u cloudu na osnovu prethodno definisanog razvrstavanja, nadograđuje se na postojeću bilo koju tehniku ili uređaje koju zgradi rade naravno digitalnog tipa i cilj je da se postigne konačno jako visok rezultat. Koje su to aplikacije koje su trenutno razvijene? Nećemo čitati nazive, to su praktično moduli, ali da vidimo koje su nam ciljne grupe. Gradske vlasti, operatori mreže, bez obzira da li se radi o elektrodistribuciji ili o daljinskom grejanju, ESCO kompanije, građevinske kompanije, menadžeri objekta, prodavci, prozjumeri, agregatori. Sve na jednom mestu. Da vidimo i gde su se odvijala ispitivanja. U Grčkoj, Španiji, Finskoj i u beogradskom naselju Vojvode Stepa. Zaključak je, kao prvo, sad kad imamo ovo trogodišnje iskustvo, već smo i sami došli do nekih zaključaka kako se platforma može unaprediti. Zato je i ovaj pomak da tek možda sredinom ili krajem sledeće godine bude dostupna i za javnost. Dokazali smo efikasnost, simulirali smo čak i modele ugovaranja i stvarali upravo te nove vrednosti, znači sav taj deo uradili onako kako bi to trebalo da funkcioniše i s obzirom da je projekat tek završen, pred Evropskom komisijom ga branimo u februaru, već imamo najave da će tražiti da se formira još jedan trogodišnji projekat koji će predstavljati nadgradnju svega ovoga što smo uradili, tako da nam je to na određen način najveće priznanje da smo na dobrom putu i da smo uradili dobar posao, ali tek smo počeli. Ja vam se zahvaljujem na pažnji, ako ima nekih pitanja, sa zadovoljstvom ću pokušati da odgovorim.
Puno na prezentaciji. Pokrivate jako lepu temu i ono što je interesantno je definitivno da ćemo svi zajedno učiti o veštačkoj inteligenciji i primjeni, tako da radujemo se nekim sledećim prezentacijama da vidimo kako napreduje. Ono što bih pitao danas je, spomenuli ste usaglašavanje sa net zero i formiranjem skladišta energije i spuštanjem referentne temperature za grejanje. Da li su određeni neki rokovi i koje načine planirate da primenjujete u tom sistemu?
Izvinjam se, u Evropskoj uniji su rokovi određeni i target je 2050. godina sa određenim ciljevima za 2030. Trenutno je u proceduri kod nas priprema izmene zakona o planiranju i gradnji, koja će posebno jedan svoj segment dati i zgradama približno nulte energije. I trebao bi da usledi u narednih godinu, 2 dana i poseban pravilnik koji će to regulisati. Ono što je kod nas problem, otvoreno da pričamo, će biti investicija i praksa. Sigurno da postoje preduzeća koja će moći to da urade, moći će da se urade i više stambene zgrade koje će biti ili zelene, skoro nulte ili nulte, ali po sadašnjim analizama koje smo radili, cena kvadrata u tim zgradama bi bila dostupna i jako malom broju ljudi, tako da masovnija primjena za sada nije moguća. U akcionom energetskom planu do 2030. godine, koji je trenutno važeći, sa projekcijama do 2050. moram da priznam da se skromno pominju ove oblasti koje ste pitali, ali treba za 2 ili za 3 godine da se radi revizija, tako da stvarno je, ajde da kažemo, pritisak struke da se poboljša i da se konkretno neki rokovi i neke aktivnosti u planove unesu.
I drugo kratko pitanje, je li ESCO dokumentaciono potpuno spreman?
Jeste. Trenutno imamo 5 većih ESCO kompanija u Srbiji koje su, slagaću 70 ili 80 ugovora već napravile proteklih 5 godina, od kojih najviše sa privatnim kompanijama. Znači, privatnici su prepoznali taj važan segment da imaju benefite, a da ne ulažu mnogo, a ESCO kompanije su naročito zainteresovane, evo trenutno u sali pored gospodin Rakić i kolega Bojan Bogdanović iz EBRD-a pričaju o javnom pozivu koji je završen i gde je izabrano 21 javna zgrada za kompletno pripremu, izradu projekta koji će biti ponuđeni dalje ESCO firmama koje žele da preuzmu ovo i naravno uz određene donacije kako bi to sve zaživjelo u cilju promocije.
Hvala najlepše.
Next presentation in that case will be my presentation and my colleague
Petar Petrović, Beyond the Carbon.
Hello everybody from different position now. We will speak about regulations, we will speak about F-gas regulations, we will speak about possibilities, and we will speak about opportunities, and the main opportunity is of course to stay alive in coming period and to live the earth in the condition that our children and grandchildren can live properly from now on. So I summarized this in one sentence: beyond carbon and beyond life. This really shouldn't be a question. I think that we are all clear that all the risks that are coming from the fact that we cannot reach the targets that are year by year set by international communities and regulation makers are coming very important, and this is a topic that is considered by many people, but the results are still not as they are expected. What we have in this regard is that by 2050 net zero emissions should come absolutely to zero, and there is no alternative any longer. So most of these regulations and everything related and around that could be summarized with this, and I think that this is really a very clear message and very clear expectation that we should be careful about in future. Of course, as always, we have many challenges, and many challenges are summarized also in climate change, different technology disruptions. We spoke about artificial intelligence, which is mentioned more and more, and we are part of overpopulation and pandemics that are lately taking place in our lives, and that are mostly related to this climate change and all these related effects. Of course, from the other side, we speak about some things that are called uncertainties, and they are coming to be normality, which is sometimes difficult for us to understand, to accept. We have a continuous relation between West Bloc and BRICS, energy crisis, shortages, surging cost of living, destruction of nature and communities, and one of the things which is very important for us, that war is not the last choice any longer. We see that in every part of the world we have crises which are very frequently coming into big crisis and wars, which is, according to normal people understanding, not as good as maybe result from that is expected. Deglobalization is started, so we have clear development of global trends that are coming to come back on local level. So the global is only thinking and global is strategy, but real activities are coming more local or coming back to be local. All sharing significant contributing factor, and dependence on fossil fuel is still very present because of the facts that are mentioned. If you see, we are really having life in bad dreams since 2020. It started with Corona, then it started with the financial crisis, and lately last year we had the starting war between Russia and Ukraine, which was continued in Middle East. All this is creating new normality, which is very stressful and very problematic for development of normal life in Earth. The message or decision that came from that point, or the result that was considered by many regulation makers, is that it's really a final time to escape the fossil fuels. Unfortunately, maybe this decision came from the war crisis in ex-Soviet Union, and maybe it was much better that this came much earlier because of healthy reasons and because of development of Earth like living being, but it came, and we are happy that it came. So we are expecting that all this development will increase the renewables utilization all over the world, and most of the activities that are made lately are making the development in the way that renewables are taking much more place than it was before. At this moment, the conference in Dubai, which is COP28, is going on, and they are discussing this International Energy Association and International Renewable Energy Association policies, which presented some targets for 2030. What is expected and what is coming from the couloirs of Dubai meeting is that as a result, the announcement will be that renewable concentration or percentage will be tripled after the conference in Dubai. So what we expect from conference in Dubai is that renewable energy will really skyrocket, because the Paris Agreement 1.5 degrees increase of temperature is absolutely not realistic, and the assumption is that only by tripling these expectations we can come to the point that by 2050 1.5 degrees Kelvin difference delta T can be reached only if by 2050 net zero will happen, and by 2030 we have 3 times more renewables than it was calculated. You see the graph how that is calculated. If anybody is interested, we can of course share some more details. So this is in highlights what will happen in Dubai. They will announce 3 times increase of renewable energy, and the highlight is also that the previous 40% part of renewables in total energy consumption in each country will be declared as obsolete and not valid any longer. We will speak about 45 to 50% of renewables, and this is not some kind of free empty discussion. This is clear message that will happen, and the countries will be absolutely obliged to follow these proposals. Heat pumps expected to exceed 50 or 55, and REPower EU targets by 20 million. So former numbers will be increased for 20 million heat pumps, which will result in, as at the moment spoken, 60 million units in Europe in year 2030. So we speak about huge requests from designers, from HVAC population, from manufacturing facilities. There will be a jump of production, jump of supply, and jump of utilization of these kind of products. These graphs are showing this. I think that this graph is more important. You can see that some of the countries, especially in Baltic region, in Scandinavia region, already declared 100% renewable energy, 0% fossil fuel by 2030. These guys will not sleep peacefully if they know that, for example, in Serbia, we will still have coal dependence by 2050. So this is clear message. I think that all these discussions that we are making last days should be somehow transferred to decision makers in Serbia, because with this development, I don't think that we will be able to pay enough taxes to survive dependence on coal in coming years. The graph is sourced from very important sources, and you can check it in most of decision making and policy makers in Europe. It's something that we should be really careful about in coming period. Dependence on gas is a really hot topic. There is even a strategy. I didn't want to emphasize war between Russia and Ukraine, but there is a strategy by European countries how to get independent from the Russian gas. There are 9 measures to eliminate Russian coal and fossil gas from Europe by year 2025. If this is not ringing a bell, I don't know what can ring really a bell. This is another topic, how gas and coal will go out from the utilization. So again, message clear. Policy makers are clear, the technology is clear, only we should try to use this information that is free in the moment flowing around Europe, how to define development of HVAC in our country and of course in the countries where we would like to be present. The energy transition investment trends. Last year was the first year where investments in renewables reached or topped the investment in fossil fuel. This is very good sign, and according to the expectations, it is really expected that this trend will follow further, and that the investment in renewables will grow, and that fossil fuels will slowly go and fade out. Also some graphs showing similar things. And coming to Serbia. Serbia is at the moment critical for all of us. There is no clear strategy presented to Europe. There is no information which went what will happen in Serbia. The only information that is existing is that the strategy is that Serbia will become independent from coal by the year 2050. This was not very nicely accepted in this information flow, so there will be a demand that from Serbia we send some new messages. How do we plan to do that, and what do we plan to achieve? If you see the graph below, the black part is dependence on the coal. It's 62.3%. We have some hydro potential, which is of course existing from previous times, luckily for us, otherwise we wouldn't have even much of that. So there is huge opportunity. We speak about possibility either to say, okay, we don't have anything and to cry about that. I think that it much better is to see it as opportunity and to make all possible activities to resolve this and to make the blue and green line a little bit more wide. How this is planned to be done? We have different policies. One of them is International Energy Association Net Zero. The other is National Energy Protocol, Fit for 55, Repower EU, Current Outlook, Optimistic Outlook. You will see now what these outlooks are giving. All this development is meaning that there will be a huge jump in renewable energy, and that will be a huge jump in utilization of heat pumps. This is something that we should be really careful about. There is also a graph that is showing how much gas in Europe will disappear from the scene in very short notice. And we are coming now to the important point, to industrial. We speak about scope 1, 2, 3. Scopes 1, 2, 3 are speaking how industrial facilities should organize their supply chain and their position in the market to be able to become carbon neutral. We speak about scope 1, which is related to logistics, to supplies, to semi-products. We speak about scope 2, which is actually the plant, factory, production of each facility. We speak about scope 3, which is related further on the line downstream with the supply chain organization. What we are usually focusing is the manufacturing part, and in manufacturing part I can give you few examples. Actually, I will not name them because I have NDA in Serbia, where big industrial facilities are requested from their mother companies and their market to become carbon neutral by 2025. This means that they either need to have clear energy for supplying of their heating, cooling and ventilation, either to produce their own energy to do that. Because of slow procedures in Serbia, they are mainly deciding to invest in solar power plants and this kind of solutions to be able to continue their productions. Otherwise, there's their buyers who are already warning them that they will not buy any products from them any longer. So from that perspective, we are again in the period which can be also treated as opportunity, that all of us who are making some kind of relation to HVAC think about that, how to resolve these things. This is huge potential, and I think that it should be used before somebody will say that it's a little bit late. Heat pumps. This slide for me was really astonishing. This slide is actually showing what will happen in Europe if 60 million heat pumps will be installed by 2030. I will just read you a few of the things. Expectation of 40% decline in emissions, 2.5% increase in GDP, 60 billion saved on energy imports, gas demand in buildings falls by 40%, 46% fall in CO2 emissions, heating bills are over 20% cheaper in households, and one which was very impressive to me, I was very surprised, 3 million jobs created in Europe. So 3 million people will be employed if 60 million heat pumps will be installed by 2030. This is, again, huge potential, saving our lives, having a healthier atmosphere in the world, and in Europe, in our country, and of course, creating opportunities. 3 million people employed on European level. This is huge amount of people for that. Again, we have some information that will follow in next week from COP28. 45 to 50% expected by 2030. This is not a game any longer. It will be very obligatory. And plus 20 million heat pumps compared to the previous announcements. Trends and influences. Eco-friendly HVAC will rule the market. We speak about a long time. F-gas is going to disappear sooner or later. We are now in last 10 years of fighting what freon can remain, which freon will go out. Very soon we will speak about natural gases, meaning propane, CO2, ammonia. I think that freon will be limited maybe to 1, 2, 3, 4 ZE and maybe to some new which will appear. But in general, natural gases will remain as a main refrigeration media in HVAC. Internet of Things, connectivity, smart HVAC solution, systems going to become ductless. That is very important. Everybody are keen to save on cost of material, and ducts will be definitely one of the topics to disappear in sooner future. Of course, macroeconomic influences, as we spoke, especially related to the wars, are getting worse and worse. This graph is showing actually what we spoke in previous slide. It's only shown in a little bit more understandable and fast noticeable. The gases I mentioned, the line of flammability is a little bit restrictive in the moment, but even the gases which are flammable will be used in future. You see that most flammable gases are actually something that will really continue the game. Propane, propane, ammonia, and CO2 are leading the game. And according to international affairs, I was in Chilventa in Nuremberg earlier this year. I didn't even see one freon chiller or heat pump exhibited in that exhibition. So it's becoming history very shortly. I will just present you some references that we made in last period. first reference that I will mention is Factory Continental Novi Sad. We are very proud of this reference. We will have in 3 stages approximately 20 megawatt of heat pumps installed. The reason that I am especially emphasizing this project is that Continental is absolutely the first investment in this region which happened to be independent of fossil fuels. Even the first stage, which was made with the gas heaters, was in second and third stage revised, and they are using high temperature heat pumps to recover the energy which was originally sourced from the gas heaters. So we will have complete factory running on heat pumps, and we are very proud of that we actually delivered this solution and that we participated in this project. I think that this is really a very good example how very quality and high level global organization is thinking about future. They are appraised by Golden Lead, but I don't think that Golden Lead was main motivation for them. I think that the main motivation for them was to become fossil fuel, especially they are coming from Germany. Germany is still the largest importer of gas in Europe, and that was extremely important for them to show that the German company is absolutely fossil free. This is first project that we are very proud of. Second is another German project in Kruševac. They, Henkel company, they switched 4 new facilities to the rooftop design that we also helped them to set. We delivered the solution with special high induction ducts that are providing very low temperature of air for heating facilities. We speak about maximum 35 degrees of air to heat up the facility to the needed temperatures. When they have temperature in facility around 18 or 20 degrees, we are coming to the point that air temperature can even be lowered to down to 30 degrees. This is another proud project for us, and we are very happy that we started these solutions. We also resolved new air distribution in Sava Center. We speak about same high induction distribution of air, and this high induction distribution of air is providing really very low temperature. Since the new Sava Center was started, we were delivering 30 degrees, maximum 30 degrees of air to reach 21 degrees in all levels of the building to be able to have heating without destratification and very uniform temperature distribution all over the building. Next project that we would like to present is IKEA in Belgrade. In that project we used the high system for very innovative recovery, thermodynamic recovery that we are using in our fresh air supply. We are using special units which are compact units with integrated heat pumps. So what was achieved in IKEA retail park is something that is especially important for us, because in, I think, almost 80% of time they did not even start the heating. They were only using this fresh air, 100% fresh air supply with the heat pumps compact in the units, and being able to achieve a set point of the temperature in the system. Of course, during the, let's say, little bit demanding weather conditions, they minimized energy that was used. We were sending isothermic temperature inside, and again, they minimized the energy consumption. Next is back to heat pumps. We speak about renewables. Heat pumps are very important for us. We are delivering solution. The most important solution, especially for myself, I really like it as a person, and technology is all absolutely very important for these climate changes. We are using 4-pipe polyvalent heat pumps to generate lots of free energy coming from waste energy, which was usually in 2-pipe system lost in these kind of facilities. We especially speak about commercial buildings like hotels, like retail parks, like shopping malls, where we have lots of demand for this kind of waste energy from the reversible side to be able to heat up the sanitary water or to heat up the swimming pools or whatever areas. We have a hotel in Montenegro. It was absolutely crazy for us. They are spending 2,000 euro monthly for heating all sanitary water and 4 swimming pools, 3 external outdoor and 1 indoor swimming pool with 2,000 euro cost for 10,000 square meter building. Absolutely brilliant. They are using all kind of energy, solar energy, and especially they are getting so much free energy from the 4 pipe systems that we are providing. I will not mention so much about this project because that was only high efficiency screw inverter chiller, which is using water as a source for cooling of the condenser. Impressive building, 5 megawatt cooling done in very efficient way, but I think that even with this kind of buildings they can do much more with utilizing heat pumps and four pipe heat pumps. We are speaking to these guys and explaining the advantages, and I hope that in some of next projects we will have this development. Again, 5 megawatts, only one building. Project in Belgrade, 1.5 megawatt 4 pipe system. Again, utilization of really big amount of waste energy. They're just finalizing their spa and big swimming pool. All of that will be heated without even 1 penny cost. They will use all the cooling to have this energy fully free of charge. This is small thing, but very important for us. We have first nearly zero house. This house was from April to November, 0 grid energy consumption, heated by heat pump, 10 kilowatt hybrid solar system, and from November to February or March they will have so much minimized cost of energy. We have first nearly zero that we are aware of, and we are also very proud of that. That was mostly what I wanted to say today. I hope that we can remember that in Serbia we still don't have strategy, that we still didn't announce our policies related to green energy, and I don't want to use that as a bad information. I want to use that as opportunity, because we have huge opportunity. Somebody was speaking about in previous presentations about district heating in Serbia. We have district heating developed in much better way. I think that Mr. Andy Pearson will confirm that in UK they would cry after this kind of central heating, because they have lots of needs and they are inventing the central heating in UK to come in position which we already have in Serbia. So I think that we should really take it as opportunity and think how to reduce the temperature in supply of the central heating, and how to make the energy banks, which were discussed by previous presentation. I am very happy that our authorities are starting to think about that. Thank you very much. If any questions are there, I would open to answer.
Thank you, Petar.
Thanks.
It's a very nice presentation. I think Andrei Lukashkin is here now. It's presentation is ready.
Yeah,
so the presentation, he will present again natural refrigerants for the refrigeration.
So, very good. Now it's working. My name is Andrei Lukashkin. I am from a Carel company. Carel is an Italian company historically, which is a manufacturer of electronical components, controllers, and high efficiency solution for refrigeration direction, for refrigeration equipment. Okay, it's here. So, my colleague told to us that market trends is to use high efficiency technologies also for refrigeration market, and our customers and users, retailers, require to use more and more and more neutral refrigerants, because neutral refrigerants and IoT technology to manage these technologies in the correct way, in high-level way. I will tell you about it sometime later. Why natural refrigerant? Because the costs of neutral refrigerants is really low compared with HVC. And it is not so dangerous if we are speaking about emissions and if we are speaking about caring about nature. So you can see here a roadmap starting from 1987 and till now, and it was a lot of countries joined the Montreal protocol, and after it was a new F-gas regulation. Now we have a new F-gas revision to reduce of usage of HCFC, HFC refrigerants, and the trend is in the near future most popular refrigerant will be CO2 and propane in Carl opinion. So on this side you can see some restrictions to use fluorinated refrigerant according to the application, and you can see that it is a requirement which will start from 2025 that GVP of refrigerant must be less than 150. It is for commercial refrigeration equipment and also for industrial application and for let me say any application. It is a general trend for small sizes of refrigeration projects and for biggest project. You can see that the main target to reach zero level of usage of HVC refrigerant in 2050, and step-by-step strategy is to reduce level of usage of standard HVC refrigerant. And what is the new to reach this target? You know that now restriction for green propane for green refrigerant, which is a propane, is refrigeration load must be less than 150 grams in one circuit. And starting from next year, we will apply new regulations and we will increase the level of refrigeration load up to 500 grams. And it is a give a chance to OEMs of refrigeration equipment to decrease quantity of circuits and to make refrigeration RX more cheaper and to make neutral green refrigeration RX more cheaper and in this case more available for end users to use it in refrigeration projects. So you can see on this slide how Carl is growing with a project based on neutral refrigerants. Starting from 2016 we start to produce special controllers with a special logic to manage CO2 circuits and to manage circuits based on propane. And now we have good results. We sold more than 1,000 pieces of our controllers, especially for high efficiency CO2 solution and for high efficiency propane solutions. So it's trend, it's maybe European trend, and we are thinking that trend will also arrive to Serbia, maybe a little bit slowly, but we are sure that in the near future, step by step, Serbian market also will use more and more refrigeration system based on green refrigerants. So, just a couple notes that now Carl is investing more than 5% from general Carl Group turnover to develop and to research new technologies related to neutral refrigerant. It is a big investment from Carl's side, but a lot of European countries also and companies invest also a lot of money to support this trend. It is a trend. So we have a special devices now. We have a special electronic expansion valves to manage evaporators based on CO2 and propane. We have a new BLDC compressors. It is a DC technologies, and we have a smart business monitoring system to analyze and compare results and improve and develop new solutions and to show to our customers, let me say, differences between old and modern technologies. So we are thinking that we will have two trends for CO2 and propane. For centralized system, we are thinking that for different sizes of stores and project, we will use refrigeration racks based on scroll compressors, and for convenience and small stores, petrol station, we will use BLDC technologies because it's already available on the market, and we have a cooperation with a Toshiba company, and we are producing for us BLDC compressors, especially by Carl design, let me say. So different solutions for different sizes of projects, different controllers for different sizes of refrigeration racks. It is our new controller. We start to produce this controller in this year. So there are some smart logic to manage CO2 circuits for small refrigeration racks, plus possibility to use a mobile app to have a remote control of refrigeration units. And yeah, now we need just to have a smartphone to control a refrigeration rack from, I don't know, from Italy in Serbia, for example. What is BLDC technology mean? We have some solution for small projects. We call it a HECU, High Efficiency Condensing Unit. It is a kit of components which are already pre-calculated, and this kit is a solution for local OEMs to start to push market to start to produce CO2 condensing units. The kit consists of a BLDC compressor, smart HECU controller, power inverter to manage speed of controllers from 0 to 100% of capacity, special terminal, electronical expansion valves, and temperature and pressure transmitters. So you can see the difference between on-off technologies and modulating the control of this refrigeration unit. You can see that the differential between set point and the current temperature is really low compared with on-off technology, and it is the reason why it is a high efficiency, because we don't need to waste energy to reach set point, in this case with BLDC compressors. So Carl also working with a local market, and now we have a focus on in cooperation with local universities, and this week on Tuesday we opened a new cold room with a high efficiency condensing unit in Belgrade University to give a chance to university to develop and research new technologies, also to show these technologies to students and to local installers and contractors, because it's something new, but yeah, we must to let me say develop also training processes here, and we hope that it will help to local market also to increase the high efficiency of refrigeration project in Serbia. So the same strategy for different countries, but if we are speaking about ex-Yugoslavian countries, we have the same cooperations with university in Zagreb, in Split, in Rijeka, and the main target also for in cooperation with university to compare on-off VCC and BLDC technologies to be sure that we choose the correct way with neutral refrigerants and high efficiency solutions. And here I told you about a centralized system. On this slide we are thinking that we have one in our trend now in European market to use a decentralized system. What does mean decentralized system? That we will have some quantity of units which we can install on the roof of refrigeration cabinets, and after it make water loop system for, to move heat from refrigeration units outside, and it must be a really suitable solution for also convenience store and petrol station in our opinion, because even here in Serbia, I think you know that one of the main main retailer delays, we have a lot of convenience store like Shop and Go, for example, and equipment inside these stores is really old, and what is the problem inside these Shop and Go stores? That we have not a space for machine room, and in this case it is a suitable solution because we can use a roof of refrigeration cabinets as a machine room, let me say, to save space inside the store. So the concept is more or less the same. There are BLDC compressor inside, power inverter, electronical expansion valve, and a smart controller with a smart logic. In conclusion, I can say that we think that the trend with neutral refrigerants will come also to Serbia really soon, and we must to prepare market and local companies, local contractors to work with new technologies, with new refrigerants, and so we are open for cooperation in this case. Yeah. Thank you for your attention. If you have some questions, please. Okay, thank you.
Thank you very much. I have really great honor to announce next presentation, that is Professor Marija Todorović with the topic Transportation Data Centers, Energy Efficiency Optimization and Greening aimed to the decarbonization.
See the title, Introduction. I have to 5% of global CO2 emissions are generated with ICT sector, including data centers. A number of power of the aviation and marine, air and marine system sectors contribution. Data centers are estimated to have the fastest growth in carbon footprint from across the whole ICT sector due to technological advances, cloud computing, and growth of the use of internet. There are practices that the data center sector could be using 20% of all available electricity in the world by 2025 because of the large amount of data being produced by the enormous speed. Study objective of DC technology and design methodology to the energy efficiency optimization of a high-density data center based on relative performance analysis, remaining data center energy efficiency to the level characterized by the power usage effectiveness as closer as possible to 1. Power usage effectiveness 1 has been successfully realized, taking an energy efficiency optimization road to a higher energy efficient data center of the IT and energy performance. Transportation data center for maritime. Using the long-range identification and tracking system was initially set up for the purposes of maritime security, but soon its use was extended to search and rescue maritime safety and protection of the maritime environment. Ships send automatic position reports every 6 hours, which are received by satellite and satellite transferred to the RRT data centers. The EU Cooperative Data Center disseminated RRT information on EU-flagged ships and exchanges information with other DCs around the world. It is one of the largest data centers in our IT system, tracking over 8,000 ships per day. Transportation data center for aviation. Importance of broad spectrum of data in aviation has been recognized as early as the aviation had been born. To allow ground rules to identify potential faults before they become problems, improving aircraft reliability, reducing costs and delays, important are data and their analysis for predictive, prescriptive alerts to take surprises out of maintenance. Commercial airlines are data generators, producing more than half a terabyte of data in a single flight. And use of these data via analytics apps can reduce aircraft energy demand by approximately 10%. Source Boeing. One among the best known data system for aviation, CAPA, CAPA, Center for Aviation Data is the hub for all data relevant to the aviation, including traffic, financials, and other performance data to the aviation, companies, and travel industry. Integrated sustainable building design. Energy supply is one of the crucial topics of powerful data centers, secure, uninterruptible, and superb high performance. To reduce the data center impact on the environment, key experts and stakeholders in all relevant multi- and interdisciplinary fields spanned worldwide are putting collaborative efforts to approach the carbon neutral green data center. Historical data center design process was similar to all other types of commercial buildings for specific purposes, consisting of the architectural building design at different precision level, involving the consultants, building service engineers, mechanical, electrical, particularly IT sector, subsequently later in the design, development, and in the construction document phases of the project. In order to really approach carbon neutral data center and further sustainable and zero fossil energy DC, the entire project team must be involved from the first moment at the pre-design phase, conducting the whole project development process as an integrated, sustainable building design process. Study approach and objective. Establish IT integrated DC design. the most current knowledge and creativity through every phase of analysis and design to its substantial environmental benefits during its entire life cycle. Identify, predict, and implement cost-effective opportunities to optimize the design of the pre-implement leading energy environmental innovations. Project facility concerned building structure, technical system, energy and structural materials, efficiency. Reducing in CO2 and other greenhouse gases emission, environmental sustainability, and indoor environment quality. Achieve green data center communication, IT building, improving its overall function and reliability of a data center. Feasibility study for the NS Europe. That was the project which I did with my team. In the case of DC, integrated sustainable building design, every design subsystem segment has a specific aspects, intrinsic goals and criteria and requirement the design is to satisfy, and these aspects are also to be satisfied within the complex integrated sustainable building design. Hence, our integrated sustainable building design of our DC case study model is to encompass particularly through the IT infrastructure and system, additionally integrated design optimization. There are our team from architects, construction, and my firm were in virtual engineering and investment division in Belgrade. DCM energy efficiency, optimization, and green as definitely to be harmoniously growing with all specific aspects relevant for DC building segment, IT, architecture, HVAC, lighting, water supply, and sewage, fire protection, suppression, security, design aspect, as well as renewable energy supply. Main activities: building site provision, architecture, structuring, engineering, general services design, DC, technology, HVAC and energy supply, integrated building and HVAC system and other technical system, energy efficiency optimization, and optimization of the energy supply mix, including alternative renewable energy sources implementation. Technology and building services support infrastructure service, lighting and other electrical system building, telecommunication system, including sound and electronic security and window system, water and sanitary, sewer installation, fire protection, fire suppression, equipment power, cooling density analysis, electrical power, gas, fuel, cogeneration, tree generation, mechanical engineering services of ventilation, heating and air conditioning system with the introduction of geothermal water energy sources, gas supply, and facilities in building. Environment and renewable energy sources available, cooling and HVAC system, relevant outdoor condition design load and dynamic behavior, prediction of typical meteorological data, available solar, radiation and other natural resources availability, all relevant feature, hydrogeological conditions are relevant for underground water utilization, solar radiation excellent for the implementation of photovoltaic conversion to the electricity supply, photovoltaic produce electricity up approximately equal to the aircraft artificial lighting plus control, automation, and bulk building management system. Climatic and hydrogeological data, relevant outdoor condition, determination of dynamic behavior via building performance simulation, typical meteorological stuff, the building dynamic behavior prediction shall quantify energy requirements and losses for each building subsystem and component for each hour of the relevant typical meteorological year for case building center modeling location. Also, as a part of climatic conditions, can review data related to flood risk and control. Hydrogeological conditions for underground water utilization, groundwaters can be used as wondrous renewable source. For following data center, for floating data center are relevant climatic data and marine data, depending where DCM is floating or is underwater, fully underwater, relevant design parameters, three-dimensional wall, barge or ship, water environment and so on, water temperature field, water motion, relevant velocities and acting sea level, and underwater pressure and forces all year round. World Meteorological Organization with an associated series of national organization is providing absolutely abundant corresponding necessary data. Optimized IT solution for DC is to order to have completely correlated and matched system selected has been the best particular solution with explanation of regarding DC, data center architecture design, maximum number of racks, data center usage, over subscription ratio, number of servers, storage capacity, telecommunication connections, power supply, physical security, and fire detection system. Enormous quantity of necessary data. The whole team was working and designed. This is for DNSU, was designed in Belgrade for one location near Sava River. Architectural design, you can see vision, and on the right side there is floor where are racks exactly distributed. IT infrastructure and services, design models, data center, the service cluster data center with Ethernet, all relevant features, storage area network, mitigation to sun, principles for sun design, large core edge sun design, virtualization, cabling, access, floor cabling, distribution design. Here is multi-tier model, scheme, and server cluster model with ICMP. Large core edge sun design, the relevant data, the numbers are given. Virtualization in sun, comparison between old sun time and new virtualized sun, providing power and space saving while easing management. You see separate infrastructure to achieve strict fabric isolation, and then on the other side, virtualization of sun director and fabric to achieve strict fabrication. Royal layout and block diagram as a complete, all connections, IT equipment power and cooling densities analysis, that is very, very important. Final IT solution and equipment specification determines power consumption, footprint of racks, rack layout, important for heat dissipation and distribution, heat dissipation based cooling specification and HVAC and cooling system and equipment design. This is the virtual types of construction walls, internal design criteria, HVAC system zoning, thermal conditions, heating and cooling loads. searching a route to DC HVAC and cooling system, high performance and sustainability. Rack number and equipment, detailed analysis, calculation, power growth, you see, prediction on the left side, then prediction of rack equipment power growth, prediction of number of racks of different loads. Selected route of DCC and cooling system, high performance and sustainability, application of the combination of HPC and precision control, finally confirming the airflow to the thermally high loaded racks, and the room air conditioning for the basic air conditioning DCC's thermal loads. Implementing special air distribution elements to combine the airflow through the rack and around the cooling elements directly cooled by the refrigerant evaporation, it's possible to enhance significantly the convective cooling within the rack. Important criteria in selecting the proper system was air quality and its strict control of temperature and humidity. The direct refrigerant-based HVAC cooling, high precision air conditioning, meaning you can see the picture of fluid flow, temperature field, and the directions of happenings and flow. Here is a definition of different of systems defined and structured for the DCC mechanical and system optimization. So all these models are designing and calculating both in synergy, mechanical and system optimization. It's too detailed, too long to be all read. Here are graphs are following result of calculation for this system design for all year round for cooling. You see, it is annual sum is 386 2,002 kilowatt hours. Renewable energy supply, photovoltaic electricity, you see there is available on the roof, mainly of the building, and on the side one, lower and high, more than 1,000 square meters, module number more than 1,000 PC, powered also P maximum and installed. So results, 5 different model scenarios. So this is energy supply system. Are for results grid electricity and diesel generators. The S system, the 2 grid electricity PV and diesel generators. Energy system 3 grid electricity I cell and diesel generators. ES5 further greening approach, dual fueled, 3 generation, grid connected, PV, ICE cells, and diesel generators. There are any system to be sure that there will not be neither seconds without any operation, but all secure and as designed. Combined MCS scenarios are here, just how it were specified by relation to the earlier design systems, electrical, and here are input power of different models. Scenarios are given, input power necessary in kilowatt even. You see the best one is on the right side, green colored. That is for system 9. Here is again annual electricity consumption, then annual electricity, then scenarios power usage effectiveness. So based on all these partly show results concerning electricity load are calculated these values for these data centers shown here. This is not on project scenarios and project system, but this is, I did find in the US, in California, data center. So that is diagram on this diagram till 19, number 19. Those are those systems in US, and you can see that this power usage effectiveness, only 3 best ones are down here, right? You see, light green colored, and those are, let's say, from my project, you know. And that is really great that with the approach, with careful analysis, all different elements, component system, so on, that it was possible to really design such a system. So you will see that that is all these 3 green, and this is exactly in Lawrence Berkeley National Laboratory near San Francisco. And power usage effectiveness, I don't know if you know what is that quantity. Power usage effectiveness is the ratio of power used totally and divided by power used just for data center operation. So the total amount, which is counting energy used for air conditioning, that and many other also needs, and divided by what is only for racks and data center itself working. So data center feasibility study results. The main goal was to obtain cost-effective data center of precision level of performance, effectiveness, and efficiency, as well as of maximum reachable energy efficiency concerning the most current technologies and techniques development. The electronic equipment is characterized by continuous miniaturization proceeded with density growth of specific electrical power input and dissipated that heat released of service and storage devices are continuing to increase at a rapid rate, and need for incentive cooling is in permanent extreme growth. From the final solution, the following was derived: specification of equipment, power and consumption, footprint of racks, rack layout important for cooling specifications, heat dissipation crucially important for HVAC, particularly cooling specifications. Scheme of DC's optimized IT equipment and system structure with reference to the IT energy efficiency is given in Todor de Maria and Geo Taikim. That is one laboratory in South Korea. So they were drawing more. additional greening innovation, ice thermal energy storage, so it was not another data center. So PCMs for building thermal mass control, storage heat, cool recovery, HVAC innovations, RES photovoltaic and wind electricity, wave energy, underground water, floating and underwater DC, refrigerant, direct HVAC, free cooling, groundwater cooling, natural refrigerant, CO2 emission, critical cooling, floating and underwater DC, alternative gas supply and fuel cogeneration and floating and underwater DC. All that are alternative possibilities to increase variety. Floating and underwater data centers, you can see, that can be on even totally underwater or partly underwater, and then efficiently used water cooling. More on the Nautilus project, Nautilus Data Technology Barge, DC under construction in Valley, California, has made headlines since Google first floated the idea in 2007, patient filling, and was spotlighted by Microsoft test on an undersea DC. Its 6 megawatt floating DC is announcing that it will be cheaper and more efficient than traditional land-based facilities. For repurposing companies using reconditioned military and construction bases, which are ocean-worthy and good for 40 to 50 years lifespan, as DC barge deck space used for and space below deck for power distribution and cooling equipment. Goal, coupling submarines technology with RES, marine wave offshore and energy, to develop self-sufficient underwater DC that can deliver, when necessary, quick cloud service. Quick. The deployment of Northern Isles DC at the European Marine Energy Center marks a milestone in Microsoft project NEC, research project on the manufacturing and operating environmentally sustainable pre-packaged data center unit that can be ordered to size. So, I think that evidence was maybe already. No. That was the approach. To approach conclusions, so here it maybe just once again a little bit more concise reading. So that's yeah, here yeah. Maybe yeah, I didn't. It was. I think that I went through this slide. Yes, okay. And this is one well, nice, interesting graph. So integrated building, technology, energy construction graph of data center design and method building integrated. What everything is to be integrated. Building architectural concept, IT system concept. You see with these different circles. Structural building and HVAC concept, and decarbonization, energy and environmental integrated concept, EBTech and IBTech. So you see that this EBTech is covering the section of all these others. So separate optimization in these four, but then also between these and the final here in the middle. So, thank you for your attention. Here is my email address.
ask a few questions. A few questions, is it okay? If we can ask some questions.
Please?
Okay, thanks. First of all, the information that some terabytes are related to every single flight or transport sound really scary to me. I cannot even imagine with the number of flights what is the amount of data. The question from there, could it be that these data centers are geographically centralized in some cold areas to avoid huge energy consumption? Second one was, is it possible to optimize this amount of data to minimize somehow? Is it something like plan or development? And it was very interesting to me that the safety, I understand that you need safety as an energy and you provide diesel aggregates as safety. But is there a possibility to use maybe biomass boilers or something like that to avoid, or was it related to diesel generators, electricity? This is what I didn't understand in your explanation.
So, okay, you listed everything what is necessary, and that's absolutely right. And now, concerning aviation, especially aviation, is a question of airport. I mean, airport area and the unhealthy environment to be careful, because that is the energy source for airplane. So that is also very serious area, and how many hundreds and thousands of people are passing through that. So there was a large study about just about data on aviation.
Thanks.
Okay. Thank you.
Thank you. This was the last presentation. I think that it was very interesting overview of different technologies and different approaches in this latter development of HVAC. I hope that you enjoyed and that we will see next year with more topics and more interesting research done. Thanks a lot once again.